Okay, so welcome back. Here's our next question. So the question says, by sketching the graphs of y is equal to x squared and also y is equal to log 4, base 4, okay, of 3 on the same coordinate system, show that there's a root of the equation 4 to the power x squared minus 3 equal to 0, and we are given the interval from -1 to -0.5. Okay, so we're given the two functions. So the first function, y is equal to x squared. We also have another function, y is equal to log s4 of 3. Okay, so I have to sketch this on the same coordinate system. So we start with the okay, so let me just draw the xy axis. Okay, so I have that, and also I need to draw the parabola, right? So we know that's the parabola given, y is equal to x squared. Okay, so this is the y is equal to x squared. Okay, and then what else? We have to also to sketch y is equal to log 4, 3. So now here you need to be very careful, right? If you look at this, y is equal to log base 4, 3. This is just a constant number. You can just punch that number, right? Okay, we can easily punch that, isn't it? That's a constant number. So log 4, 3, if I put this in my calculator, so log base 4, and then you have 3 there. This is 0.7925. Okay, so this is 0.9725. Just use red. So let me assume that, okay, 0.9. Sorry for this. The line. Okay. Okay, let's say this is my 0. Okay, so that's y, right? So y is equal to log 43, and this is about equal to 0.7925. Okay, so don't be scared and look at this. How do I scale? It's just a constant number, just a number. Y is equal to something. Okay, so now we're given the interval from -1 to -0.5. So let's make an assumption. Say -1 is somewhere here. Okay, -1 is somewhere here, and also negative 0. Okay. Oh, this -1 is 0.5. That's 2 pi, I think. Let me do this approximation. Okay, so let's say -1 is somewhere here. Okay, so that's -1, and then -0.5 is somewhere here. Okay, that's -0.5. So we have to check if indeed it is what a root in that interval given. Okay, so indeed the root is actually the point where these two functions meet. So you notice that these two functions, they meet at that point, right? So we need to check if indeed there's a root there. So if you have to combine these two equations into one equation, so y is equal to x squared. We also have y is equal to log 4, 3, right? So let me just equate these equal to each other. So I have x squared is equal to log 4, 3. So now I can change the this in just I can get rid of that log. Remember that if I have log a b equal to m, this is same as this m will be raised. Okay, so you end up having m raised to power of the base, right? So instead this becomes b is equal to a to the power m. Okay, so m will be the power for this base here. Those are properties not sure. So for instance, if I have log 10, x, right, is equal to y. So this is same as what? 10 to the power y is equal to x, right? So 10 to the power y is equal to x. Okay, so that's how it is. So here you can say 4 to the power x squared equal to 3. Okay, let me just remove this. So we end up having a 4 to the power x squared is equal to 3. So if I move 3 to the other side, I have 4 to the power x squared minus 3 equal to 0. So this is my function now. Okay, so this is my function. I've combined those two equations. Now come up with just one function, 4 to the power x squared minus 3. Okay, so we have to check if indeed there's a root in that interval. So we can do that by doing what? By checking the sign. Okay, the sign change, then there must be a root, right? So f of -1. So checking that f of -1 at every point when there's a root in the interval, the function has to change the sign. So we have 4 to the power -1 squared minus 3. So this just gives me +1. And also f of -0.5 is equal to 4 to the power -0.5 squared minus 3. Okay, let's see. So 4 to the power -0.5 squared, 4 to the power -0.5 squared minus 3. This is about -1.5, right? -1.59. So you notice that there's a sign change. This means that in that interval, there is a root, and indeed, as you can see, there is a root somewhere here, right? There is a root because these two curves meet at some point. Okay, so there's a solution there. Okay, so the next thing is to do what? No, actually, I've already shown that. So part 2 says we need to do the iteration using what? Newton's Rapson method. Okay, we have to do the iteration. That's for part 2, using Newton's Rapson method. So we are given the initial approximation. Okay, so the initial approximation is given as P0 equal to 0.75. So second part, we have to use Newton's Rapson method. Newton's Rapson method. Okay. So Newton's Rapson method says that find the next value. This is equal to the previous value minus okay. So this is the value function evaluated at the previous approximation divided by the derivative of the function evaluated at the previous approximation. Okay, to get the next one, right? So this is Newton's Rapson method. So what we are given here, we are given already the previous approximation. So our initial approximation is already what we are given as a previous approximation, right? So our Pn minus 1 is our P0, and this is given as -0.5 in our problem here. Okay, so we're given the P0 as 0.75, not 0.5. Okay, it's 0.75, -0.75. Okay, -0.75. All right, so let us find first the derivative of this. So we're given the function f of x equal to 4x squared minus 3. So the first derivative as f prime of x, this is equal to, so if you have a constant raised to a function, okay, let's say raised to a function u, this is the function of x. So to find the derivative of this, let me just generalize this. I have a constant a raised to u. This is a function of x or something. So to find the derivative of this with respect to x, this just be equal to the derivative of the function itself okay, u prime of x times the same function, is a to the power u of x times natural log of the constant itself, which is a. Okay, so that's the derivative of such kind of functions. Okay, so if we are to get the derivative of that, so we find the derivative of the power here, which is just 2x. So 2x, and then multiplied by the same function, and then natural log of 4. Okay, so we have to evaluate this at, because remember that we need the derivative evaluating this at the previous approximation. So our previous approximation here is p naught. So evaluate this as p naught, f prime of negative 0.5. This is equal to 2 times negative 0.5. Okay, 4 to the power negative 0.5 squared natural log of 4. Okay, so let's see if I punch that. So 2 times negative 0.5, and then exponent negative 0.5. That's negative 0.75. I don't know why I keep using negative 0.5. This is negative 0.75. Sorry for this. Negative 0.75. Okay, for negative 0.75 squared natural log of 4. Okay, so 2 times negative 0.75. Okay, not mistaken, I'm getting about negative 0.8. Okay, let me check it again. I think I need to punch this once more. Okay, let me punch this once more, I think. Okay, so 2 times negative 0.75, and then we have 4 to the power negative 0.75 squared, then I shall go 4. Yeah, 2 times negative 0.75 times 4 to the power negative 0.75, just making errors here. Okay, this is about times natural log of 4. It's about negative 4.5. Okay, 535,294,162. Okay, so that is our f prime at that point. And then also from this also to evaluate our f of x at that point as well. So f of, again, negative 0.75. This is equal to so we plug the negative 0.5 in the actual function. So this is 4 negative 0.75 squared minus 3. Okay, I think the thickness isn't that much. We just add a bit more. Okay, so this is 4 to the power. Okay, 4 to the power negative 0.75 squared minus 3. Okay, so negative 0.8189845,347. Okay, so now we can find now our first iteration. So P1, this would be P1 will be equal to P naught, okay, minus, remember that you're writing at f of P naught divided by f prime of P naught. So our first iteration, our P naught is equal to negative 0.75 minus f of P naught is this one here, negative 0.81, 89, 845, 347, and then divided by f prime of P naught, negative 4.535294162. Okay, so overall, we're going to have a negative here because of those three negatives. So negative 0.75 minus negative that 0.8189 845347 over 4 point negative, of course, 353 5294162. So this is about it. Negative 0.9305802458. This is our P1. So the question actually is asking us to perform 2 iterations. So we are remaining with 1 more iteration. So our P2, we're going to make use of our previous approximation, P1 minus f of P1 divided by f prime of P1. Okay, so let's find these two first. So what is f of P1? So f of P1, so our P1 is simply 0.9, of course, negative 3058.2458. We substitute in a function 4 to the power the same, which is negative 0.93058, so on and so forth, squared minus 3. Okay, so let me just find that. So I'll just 4 to the power. Okay, 4 to the power. Okay, squared minus 3. So this gives me about 0.3217861256. Let me just confirm. Okay, let me confirm once more. Okay, and then also f prime at that point, negative 0.93058.02458. Okay, so our first derivative of 2 times x, so our x is 93058.02458, and then 4 to the power the same, 0.93058, so on and so forth, squared, right? So let's find the second derivative, means our first derivative at that point. Okay, 9305802.458, and then times 4 raised to power that, right, squared. Okay, 0.58.024.58 squared. So this is about negative 6.182377098. Okay, so again we evaluate this, right? So P2 therefore equal to our P1, which is negative 0.93058.02458 minus f of P1, which is 0.32178.61256 divided by negative 6.18233, okay, 377098. Okay, so let me just put this in calculator. 93,058,024,58 minus 0.3217,861,256 divided by answer. Okay, so this is about it. Our second iteration is negative 0.8785313137. Okay, so approximately equal to that. So we have done 2 iterations as required. Okay, so that's the end of this question. See you in the next questions. Please share with your friends and subscribe to my channel. Thank you so much. May God bless you. Okay.